Alright, so we're going to get started here looking at measurement error. So first we're going to do the bell ringer, just go review from yesterday and finding percents. So it says, what is the percentage tax if you pay an extra $175 for a $25 item? What is the total amount you pay? So your percent is going to be your tax, or the extra that you pay over the original price. When you do that, you will get 0.07 or 7%, because this is just our percent in its decimal form. So we times that by 100 to get our percent, and so there's a 7% tax that's being paid. So that's the first part, one. The second part, the total amount is just going to be the $25 plus the $1.75, which is going to equal $26.75. So that's the total that we pay. All right, so looking at measurement error, so we're going to find the measurement error by taking what we measure and then and subtract it from the original measurement, or other way around, whichever way is going to give us our value in absolute value. So what's the difference? So negative or positive, we're just looking at the positive amount that we're off, and then we're going to take that and divide that by the original percent. All right, so it says here, your teacher will give you 2 rulers and 3 line segments, line A, B, and C, line A, B, and C. Use the centimeter ruler to measure each line segment to the nearest centimeter. Record these lengths in the first column of the table. Okay, so I've already went and did this with both rulers. So one doesn't have all the tick marks, it just has all the centimeter lines. So you're kind of guessing about where it is. So A, B, and C, I got 7 for all of them. Then when I measured with the ruler that had the tick marks for millimeters, then I was able to get it a little bit closer to 6.7, 6.9, and 7.3. Okay, so now if I wanted to find what the percent error is, we would assume that I was able to use a better measurement on all these measures right here, the one with a ruler that had more tick marks on it. So my difference here is going to be 7 minus 6.7, which equals 0.3 millimeters. And then this would be 7 minus 6.7, or sorry, 6.9, which equals 0.1 millimeters. And then the last one, 7.3 minus 7, which equals 0.3 millimeters. Okay, and I would use this column as my actual length. So now to find the percent error, I could just take my value that I got, so this would be 0.3, and divide that by 6.7, by the actual amount. Okay, and when you do that, you're going to get a decimal, and then we'll convert that decimal into a percent by multiplying it by 100. So here you've got 0.3 divided by 6.7, and that's going to be 0.045. So I'm just going to round it to the nearest thousandth. So then when you multiply this by 100, you get 4.5% error. Okay, the next one, let's see. Next one we're going to do the same thing, so it's 0.1 divided by 6.9. So this one should have a smaller degree of error. Right, there's a smaller difference. Okay, and that one comes out to be about 0.014 or 1.4%. And the last one's going to be 0.3 divided by our actual, which is 7.9. 0.3. So when we divide that, you'll get 0.041, or roughly about 4.1%. Okay, so we found the difference, and then we took that divided by the actual to get our percent error. Okay. All right, so here 13.2 says measuring a soccer field. A soccer field is 120 yards long. Han measures the length of the field using a 30-foot long tape measure and gets a measurement of 358 feet and 10 inches. So the amount of error, so how much is he just off? Well, a soccer field, if it's 120 feet, or sorry, yards, you're going to multiply that by 3 to get it into feet. So that would be 360 feet. Okay, so now we're going to minus, so 360 minus 358 and 10 inches. So the difference would be 1 foot and 2 inches, or 14 inches. Okay, so we were off by 14 inches when we did that. Now, if you're using a 13-foot ruler, you're putting a mark where the next one is, and then you're starting from that mark. So that would explain how you could get some of the error. So we know that our error is 14 inches, or 1 foot and 2 inches. So now to find our percent error, we are going to need to convert either our dimensions, our actual dimension here of 360, into inches, or we have to convert this 2 inches right here into a fraction for feet. But no matter which way you do, you should get the same answer when you find the percent error. So let's jump down over here. It says express the error as a percentage of the actual length of the field. Oops. So if we're going to use the inches, that would be 14 inches divided by, so now we've got 360, we're going to multiply that by 12. So 360 times 12 is going to give us 4,320. So 14 divided by that, it's going to give us 0.003. I'll leave it at that. It's 324, so just round it to the nearest thousandth. So we're going to times that by 100 to get our percent. So that's about a 0.3% error. 0.3% error. Okay, so it's pretty small. So that measurement was fairly close. Now it was a longer distance, so even though it was 14 inches, that's a very small amount you're off for that length. Now if we wanted to do use feet, well, you were off by 1 foot and 1/6, so 2/12 would equal 1/6. So now I'm going to divide that by 360, and we should still get the same value. So 1 plus, and then we divide that by 360, and yes, in fact, we still do get the same value, 0.003. which converts to 0.3%. Okay, so the key is that whatever your difference is, and whatever that measurement is, you have to have it in the same measurement as the original. Okay, either it all has to be converted to feet or to inches. You can't take 14 and divide it by 360, otherwise your error will be quite a ways off. All right, so next, so once again, there's a couple objects. I have the students measure. I know the exact measurement. These are just examples of what I got when I measured with the tools. So, and this is working with a partner. So you measure one in the actual, record your data, and then your partner does the same thing. Okay, so in this table, I've already went through and found the difference. So measured 19, the actual is 19, so the difference is 0. So percent error would be 0 here. Because anytime you have 0 in the numerator, your outcome is just going to be 0. Okay, the next one, these measurements were with the ruler that had the marks for the millimeters. And once again, I've already went through and found the percent error. The difference. And now we just need to find the percent. So that this is going to be the 4 and the 5. So finding the difference of 4 and the percent error on the second one. So once again, to find our percent error, it's going to be our measured error, I should say. So measure error, that is going to be equal to the difference over the actual. Okay, and difference once again is just our measured subtracted from our actual. So on the second one, our difference here was 4.4, and our actual is 110.4. So to find our percent error, we're going to take 4.4. And then, of course, if you want to turn this into a percent, you're going to multiply it by 100. So we'll go through that. So 4.4 divided by 110.4. And we get 0.0398. So we're just going to round that to 4. Okay, we're going to times that by 100 to get 4%. So the error on that measurement was 4%. Okay, the next one's the same thing. Your difference was 0.5. The actual was 27.5. So when you divide those, you get 0.01818. So we'll just leave it at 0.18. When you times by 100, you're going to get 1.8% error. So once again, to find the measured error, we just take our difference divided by our actual measurement. Okay, so same thing down here. And so the hope is that these are going to be smaller errors. It looks like on the first one we had more of an error on the first one and the second one. The second one stayed the same than the original. So the difference is 0.1 divided by 19. So because 19 was the actual, so when we take 0.1 divided by 19, you get 0.005, and we'll just leave it at that. It's 206, so we won't round the 5 up. When you times that by 100, you're going to get a percent of 0.5%. And you can do a 0.5%. Likewise, on the second one, we already did this up here. It's the same numbers. So our percent isn't going to change. It's just going to be 4%. Okay, and then the last one. So it's 0.2 over the original, which was 27.5. This percent should be a little bit smaller than the top one. Okay, so 0.2 divided by 27.5. And you're going to get 0.007, and then it's 27, so we're not going to round up. So times this by 100, and you're going to get 0.7% error. Okay, and now as you look at this, when you have more tick marks, you should be able to get a closer representation to the actual dimension. This table, these measurements didn't necessarily show that, but in general, depending on how accurate you need to be, you're going to want something that gets you as close to the actual or gives you as much detail before you have to really start guessing at where it falls in between two tick marks. Okay, so we filled out the tables. We've answered 4 and 5. The percent errors are in the table. Now that's left, we're just going to answer this quick question. So it's 13.4, off by a little bit. So Claire estimates her brother is 4 feet tall when they get measured at the doctor's office. Her brother's height is 4 feet 2 inches. Should Claire's or the doctor's measurement be considered the actual height? Explain your reasoning. So it says Claire estimates. So estimate is just a guess. So you're saying I figure you're about 4 feet. The doctor is going to be the correct one because he's actually using the tools that have a little bit more precise measurement than Claire's estimate. So the doctors. So it's done with proper measurement tools. Okay, what was the error expressed in inches? So it is 4.2 minus 4, which is going to give, well, not 4.2, it should be 4 feet 2 inches. Okay, minus 4 feet, that's going to give us 2 inches as our difference. Okay, so now we know our difference. We're going to put it over our actual height. However, we have a difference of 2 inches. We need to convert the actual height here of 4 feet 2 inches into inches. So there's 12 inches in each foot. So 4 times 12 is 48. Plus 2 is going to be 50 inches. Is going to be our actual height. Oops. I'm spelling height wrong. Okay, so to find the percent error, or measurement error, you need to, okay, measurement error. So once again, that's equal to our difference, which was 2 inches, divided by our actual, which is 50. So when you do 2 divided by 50, you're going to get 0.0 or 0.04. Multiply that by 100, and you're going to get your percent, which would be 4% error. Which for an estimate isn't too bad. Okay, so this was looking at just finding measurement of error. Once again, the more detailed your tool is that you're measuring with, the more tick marks where you don't have to make as big of a guess to where the actual measurement falls in between. So what I mean by that. So if you have a ruler here, you know, you have so many tick marks, but if you have one that has even more, right? And seeing with the centimeter and the millimeter ruler, there's 10 more tick marks in between each each centimeter, so it gives you a better chance to actually get a good guess of, okay, you can get to the 100th or the 10th easily, and you're guessing in that 1000th place. Where without those millimeter tick marks, those other 10 tick marks, you're guessing at the whole number. Okay, so to find your percent or your measurement error, once again, it's your difference divided by the actual amount, or by the actual measurement. Okay, you multiply by 100 to convert that number into a percent.